All right, I need to redo part E because day 31, part 1, I had the wrong probability. So the probability that two cars selected at random are both from Japan would be the probability of the first car being from Japan and the second car being from Japan, which is the probability of the first car being from Japan times the probability of the second car being from Japan. So the probability of being from Japan was 30%, so that would be 0.3 times 0.3, which is 0.09. So the probability that two cars in a row are selected and they're both from Japan is 0.09, or 9% of the time. So in cases where the population is very large compared to the sample, or the population size is greater than 10 times the sample size, it's okay to treat trials as independent, even when sampling without replacement, since the change in probabilities will be very small. Technically, since I selected one Japanese car that was Japanese, I reduced the total number of Japanese cars, which technically makes these not independent. But like this says, if we're dealing with all cars, okay, all cars, there's so many of them, we can assume that the events are going to be independent. All right, so now what is the probability that none of the three cars came from Germany? So the probability of one car coming from Germany, if we recall on the other side of the paper, one car coming from Germany was 10%. So the probability of one car coming from Germany is 0.1. So I'm going to actually select three cars. What's the probability that none of them are from Germany? I can think of this problem a couple different ways. If it's the probability from being from Germany is 0.1, what's the probability that it's not from Germany? Well, that would be 0.9. So we can think of this as the probability that the first car is not from Germany, and the second car is not from Germany, and the third car is not from Germany. So that would be the probability of not from Germany times the probability of the second one not being from Germany times the probability of the third one not being from Germany. And you could also call this G complement. Okay, so that would be 0.9 times 0.9 times 0.9, and that would be 0.729. All right, so now the probability that at least one of three cars is made in Germany. So at least one means greater than or equal to 1. So at least one, I want you to write this down. At least one means greater than or equal to 1. So what that actually means is 1 or 2 or 3. Why only up to 3? Because we're selecting three cars. Now, this is a challenging probability to find unless I use the complement. So whenever they say at least one, you're going to do the 1 minus the probability that none of them. Because the complement of at least one, complement of at least one is none. 1 or 2 or 3, the only thing opposite from that is none of them. So the probability that none are from Germany. Well, we just calculated that probability in the problem up above. So our answer will be 1 minus 0.729, which is 0.271. All right, so what is the probability that the first time you get a Japanese car is on your fourth selection? All right, so the first time you get a Japanese car is on your fourth selection. So I like to think of this, here's my first car that I'm going to select, and it is not Japanese. So what's the probability that it's not Japanese? Well, that's 90%. And times the probability that the second one is also not Japanese, so that's times 0.9 again. And the third one is also not Japanese, probability of not Japanese, so that's 0.9. Multiply that. And finally, on the fourth car, I get a Japanese car, so the probability of it being Japanese now is 0.3. Well, not Japanese, sorry, not Japanese is not 0.9, it's 0.7. So all of these are 0.7, my apologies. Okay, because not Japanese is 70%, because probability of being Japanese from earlier is 30%, so the probability of J complement is 0.7. So that's 0.7 times 0.7 times 0.7 times 0.3, which if you do that on your calculator gives you 0.1029. All right, so the last one we're going to do on here, what is the probability that 2 cars selected at random are both from the USA or both from Japan? So the probability that from the USA or Japan and Japan. So that's a combination of an add and a multiply. The or is add and the multiply is add. So probability being from USA times the second one being from USA plus the probability of being from Japan and being from Japan. So the probability that it's from the USA is 0.5 times 0.5. That's 2 cars from the USA, or 0.25. Probability that it's from Japan is 0.3 times 0.3 to give you 0.09. If you add those two together, the probability that 2 cars selected are both from the USA or both from Japan is 0.34. So you will not be, we're not going to worry about this on the next page. It's just something you could look up and something that's kind of fun to think about. If we did a gift exchange to decide who each person will give a present to, everybody's name is placed in a hat and each person draws a name from the hat. What is the probability that no one will draw his or her own name from a hat? So they talk about it on this website here, and the probability always ends up being 1 over E. Doesn't matter how many people. That's just something a little bit higher level. If you're interested in looking into it, that's fine. Your homework is homework number 27.